I've got to make a separate part 2, and this is it, of section 2.6, number 5, because at the end of the first part of the video, I lost power last night, and so I'm finishing it this morning. Power has been restored. So, last time we saw each other, I had just finished this before the lights went out, and we found our least squares regression line, y equals 4 minus 2x. That was pretty easy. Now we're gonna find our sum of squared error, and to do that we need this general equation we used last night. We didn't actually use it, but we found A. Now I'm going to solve for E the way I would basically with algebra. And so you end up getting y minus x times a is going to be E. Now once I have that E, then I'm going to use it to find E transpose, multiply it by E, and that's going to get my sum of squared error. Okay, good. So remember, now I know what y is, right? That's just the, those are just the y values from the data that we had. We had 4 points, so I'm going to go ahead and figure out what E is here. I had 4, 3, 1, 0. And now I'm going to subtract from that x. I just pulled that from our previous work. That matrix was this. And now I have to multiply it by y, which was what gave us the least squares regression line. So if I multiply these two matrices together, I'll end up getting a 4 by 1, which is what I need to subtract it from y. And I get 4, I get 2, I get 2, and I get 0. So that's what I get. Now let's go ahead and subtract these, and we should get E. So I'll get 0, 1, -1, and 0. Sure enough, that's my E. Now what do I do next? Fairly straightforward. I just want to find E transpose and multiply it by E. Well, E transpose looks like this. And I multiply it by E. Oops, that just should be 1. This is -1, 0. And if I multiply a 4 by 1 by a 1 by, if I multiply a 1 by 4 by a 4 by 1, let me say that again. Yeah, that's right. So this is 1 by 4, 4 by 1. I'll get back a 1 by 1, which is what we need, right? It's just going to be a number. So I end up getting 0 times 0, which is 0, plus 1 times 1, which is 1, plus -1 times -1, which is 1, plus 0 times 0, which is 0. Well, that's 2. And that's my sum of squared error. Now, for those of you who know a little about stat, there's an easier non-linear algebra way to find the sum of squared error. Basically, I'm going to take my original values, right? My original data values that we used to find the least squares regression line. And what I'm going to do is I'm going to compare that with, I'm going to compare the y values in those data values with the y values that I get from my least squares regression line. Recall that that was y equals 4 minus 2x from before, okay? So if I plug in 0 to that, I get back 4. If I plug in 1 for x, I get back 2. If I plug in 1 for x, we already know I get back 2. Plug in 2 for x, I get back 0. So now what if we compare the y values that we were supposed to get with the y values we actually got from our estimate, and we square them. So I'm going to subtract them and square them. 4 minus 4 squared is definitely going to be 0, plus 2 minus 3, well, 3 minus 2 squared, which is going to be 1, plus negative 1 squared, 1 minus 2, plus 0 minus 0, 0, that thing squared. So what I get is 1 plus 1 equals 2. Sure enough, that's what we got over here, wasn't it? So either way you do it, whether you use the old-fashioned common sense way from statistics or you use the way from linear algebra that actually gave us the way from statistics, you get the same answer.